Hi, welcome back to the Capstone project. This is episode 7, and today we're talking about storage and power supplies. So let's get started. So last episode, we talked about RAM, or random access memory. And if you watched the last episode, you'll know that the RAM is the point where the CPU directly gets its information, but the RAM grabs the information from the storage, or the secondary memory. The RAM, being the primary memory, is what gives the CPU all of the information, but it takes the information from your storage. So the problem with the primary memory is that the primary memory does not retain its information after it stops gaining power. The problem with this is that once you turn your computer off, it loses all of its information. That's not the case with storage. There's two different types of storage: a hard drive, or an HDD, and a solid state drive, an SSD. We'll go over those both today in little detail. So first up is the hard drive. The hard drive is definitely the older one, but in some ways it's also the more reliable one. The hard drive was first created by IBM in 1956, and versions are still being used today in most computers. The thing about the hard drives is that they're just able to store a lot more storage than almost any other form of storage. Now, where it's stored on is inside the hard drive, or the HDD. There are little disks, hence the name hard disk drive, which is what HDD stands for. Now, these disks, think of it like a record player. The disks are the records, and the rest of the box-like hard drive is your record player. Inside the hard drive is what's known as an actuator arm, and on the end of it, it has little magnetic heads. Now, the disks inside the hard drive are aluminum, and the way that the actuator arm interacts with the disks in the hard drive is the magnetic heads are able to read different magnetic pulses on the hard drive. Basically, what this means is the actuator arm serves as the record player's needle. Now, the needle scrapes along the record, and that's how it's able to read what's on the record and produce music from it. The same thing with the hard drive. The actuator arm uses the magnetic information that it gets off the disks, and it's read through the magnetic heads on the end of it, and it transfers it out of the hard drive. Now, as I said, hard drives can store a lot more on them than almost any other form of storage in the world. For example, most hard drives today can store things in terabytes, and 1 terabyte is equivalent to 1,000 gigabytes. So if you've heard of gigabytes, this may sound like a lot for you. If you look on your smartphone, some of the bigger smartphones may have 128 gigabytes of storage on them. If you have a tablet, maybe an iPad or something, you may have 256 gigabytes. Well, 1 terabyte would be equivalent to the storage of 4 of those larger iPads, and that's only 1 terabyte. There are hard drives today that go for many, many terabytes. There's some common hard drives that go up to 8 terabytes for relatively inexpensive prices. Now, on the other hand, hard drives, being as relatively old as they are also not the fastest. Now, in an SSD, what I mean by a hard drive being slower is that the SSD doesn't have any moving parts, and it uses flash memory chips to store the data, so something similar to RAM. Therefore, the data transfer through the flash memory chips is a lot faster than a hard drive. Other than that, it stores the data inside the flash memory chips. However, the thing about SSDs is that they're new, well, relatively new, and they're also a lot more expensive. So for example, you might buy a 256 gigabyte SSD for about the same price as you would buy a 1 or 2 terabyte hard drive, the same size, 256 gigabyte size as that iPad I was talking about earlier. Now, there's 2 types of SSDs that you can find, those being SATA and M.2 SSDs. SATA is the more old type of SSD, with M.2 being a very modern kind. Now, the SATA SSDs are going to use SATA cables to connect to the motherboard. Now, that's the same as a hard drive would use. But what is a SATA cable? Simply speaking, a motherboard has what's known as SATA connectors. And these SATA connectors are little slots that you might plug something into, like you may plug a charger into your laptop. And these SATA connectors are what's used to connect the hard drives and solid state drives into your computer. However, with an M.2 SSD, all it is a different form factor, which means it connects into your motherboard differently. On more modern motherboards, there's what's known as an M.2 slot. And so the M.2 SSD just simply plugs into the M.2 slot and then screws into your motherboard. That's a simple explanation about different storage solutions. And now let's move on to power. So here's the thing with power supplies. There's really not much to them. From an outside perspective, it seems like they just plug into the most important parts and then plugs into a wall and gives all the parts power. And while yes, that is its basic function, there's a little more to it. See, the thing about different power supplies is they're all capable of providing different amounts of power. So what I mean by that is that some power supplies may be capable of giving off 500 watts of power and distributing it among the other computer parts, whereas some other enormous power supplies are able to give off 1300 watts to all of the different parts. And now, while yes, it may be really good to have the higher end power supplies so that you never run out of watts, they're more expensive. And after all, what's the big deal with getting less watts? Isn't your computer just going to run a little slower? Well, not exactly. See, all the parts run at one speed, and that one speed requires one set amount of watts. And so, if all of your parts add up together and add up their watts, and say they need 750 watts, I mean, you could just go out and get a 500 watt power supply for cheap, but it just won't be able to give enough power to all the parts, and it's going to try to work way too hard, and it may damage all the other parts in your computer. It may try to send too much energy and short circuit wires and parts, and it may blow up itself. So that's why it's important to figure out how much watts your computer needs and get the right power supply for your computer. But in essence, yes, that is generally what a power supply is there for. It connects to your wall, it grabs power from there, and it sends a specified amount of watts to the rest of your parts in your computer. That's its main function. So that's why I decided to combine it into this video, because while there is a little bit to it, the two topics I covered today are not the longest topics. They're not the most tiring topics to talk about. So I was able to just combine them into one video. So that's the video. Thanks for watching. And I think that's going to wrap up the series. So if you enjoyed watching the series, leave some likes on the videos. Yeah. Thank you guys for watching. Goodbye.